So, hi, my name is Christina, and I'm here to talk to you about Intro to Rx. Just a caveat before we dive in, I think a lot of intro presentations are of the form, here's this thing, it's really easy, use this 1 or 2 lines and your life is better. And I really, really wish I could give that presentation. I would love to give that presentation. Unfortunately, Rx isn't something where that's possible to do. Rx is complex and it's intriguing and it's fun. It's anything but simple in a lot of respects. So bear with me. There's a lot of content. We might fly through it. I'm going to do my best to make it understandable, but it's not going to be simple. It's not going to be one line, and I hope that's all right. All right. Before we dive into what Rx is, let's take a look at the current landscape. Because if there's no problem, you don't need a solution. So, background. 2 things that interest us here today. Why do we need asynchronous work? And what is the state of that work on Android right now? Well, the first question's really easy to answer. It's because users are our friends and we care about them and we want them to have a good experience. If you use asynchronous work, you can leverage the power of servers and other really complicated back-end processes that can do things that you can't do if you're just limited to your mobile device, and you can deliver awesome experiences to your users without slowing them down, freezing the main thread, or giving them janky performance. As to the second point, there are a lot of tools for you to use. This is by no means a comprehensive listing. It barely scratches the surface of all the different things you could use to address asynchronous concerns on Android, but there's some of the most popular ones. I'm sure a lot of you have heard of async task and probably use it, but there's also futures, event buses, and of course observables, which we're going to talk about today. Because this isn't comprehensive, I've linked to a more info blog if you want to go check that out after the talk. It goes through everything on Swift and Android, or almost everything. And I do want to caveat that when I say futures here, I will use futures in the canonical sense by just saying futures. I do not mean the built-in futures, I mean listenable futures. There is a lot wrong with the built-in version of futures that can really trip you up. So here I'm using futures to represent listenable futures, which use futures under the surface but add a lot of nice functionality to it. Okay. So we have a lot of tools, and because we have a lot of tools and we're only going to end up using 1 or maybe 2, we need a way to evaluate those tools. And I'm not going to stand here and say that I have the answer for what the best evaluation metrics are, but I'm going to offer my perspective on it. And 3 of the things that I think about are when they run, how they run, and whom they affect. And when I look at these 3 things, it really gives me some perspective on what tool I should use. So if we look at async as an example, you can notice that async tasks need to be executed explicitly, and this is awesome because it means that we have control of when it starts. The work can't easily be modified in async tasks though, so in terms of how they run, you kind of kick it off, and if you do want to compose things, you can get into a couple levels of callbacks. It's not ideal, it's kind of hard to bring things together. And in terms of output, a lot of the data is very side effect-y. And if you're not familiar with the term side effect, 1, awesome concept, I would encourage you to go look it up. But 2, it's very, it has a corollary to what we use in the medical sense. So if I go and take a cold medicine, the goal of that medication is to cure me of my cold. If it turns me green, that's a side effect. That was not the goal. I don't want to be green. And similarly here, if you try to do something and then it reads from the network or it hits state and that's non-deterministic, that's considered a side effect because you can't always know exactly what's going to happen based on your function signature and the like. If we look at the code for this, you can see that bottom line, that's where we're executing this explicitly. You can see that there's a do in background there where we kick something off, and then once that finishes running, we get that callback in the on post execute, but it's not quite sure how you would compose things from there or change them once you kick it off. Okay. If we have evaluation metrics, we should probably have some ideals that we're shooting for, because otherwise, what's the point of having metrics? So I'm going to offer some ideals, which I think we should shoot for. First, explicit execution. If you can start something, you can control it. This is not always true with futures, wherein if you just create them, they're running. You want to have as much control as possible. I think in this case, not always, it can, with great power comes great responsibility. In this case, it'll help you because you can create them and you can play with them before they ever kick off. You also want easy thread management. This is a talk about asynchronous behavior. Thread management is key. You want it to be easy, and then you want them to be easily transformable and as few side effects as possible. I'm going to dive into each of these, but the basics are the same. So again, explicit execution, it means that you can play around with these observables, you can create them and store them and modify them, and right when you get them perfect, right when they have all of the data that you need, they look exactly the way you need, you can kick them off and not a moment before. Again, in terms of thread management, this is asynchronous work. If you can't easily switch threads or understand which thread you're on, that's bad because you're probably going to make mistakes because of that. So we want that to be easy because it's readable and because it's better for you as a coder. In terms of easily composable, it would be great if asynchronous work was one and done. We kick something off, network request, it relies on nothing, we don't need to do anything when it comes back, we just do it and forget about it and great. But the world doesn't work that way and often things are interdependent, and if they're interdependent, you want to be able to play nicely together. If you hit the cache and then the network, you don't want to have intermediate steps there. You want to be able to chain those together in a way that makes sense. So if your asynchronous library is easily composable, it'll introduce less room for error, and that's a good thing. That's a win for us. And lastly, minimizing side effects. The fewer side effects you have, the more easily you can reason about your code, the more easily you can read it, and you can bring someone on to understand it as well because it doesn't depend on state, it's deterministic, and it's just much easier to talk about. All right, I set these standards. You probably know where this is going. I personally think that Rx meets a lot of these, and I'm going to tell you why. So Rx is explicitly started. You have to subscribe to it if you want anything to happen, and before that time you're still building or creating or storing, and things aren't kicked off yet. It is very easy with Rx to understand which thread you are on because there are single line operators, subscribe on and observe on, where you can assign the thread. And so if you're reading code, you see an observe on IO thread, you know that's happening on the IO thread. They're easy to transform and to filter and to map and to do all sorts of other operations on. This is where they really shine. And they're also really good at minimizing side effects. This is asynchronous work, so they're never going to get rid of them. You're hitting the network, you're doing very state-bound stuff by definition, but they do a really good job of minimizing that. So fast facts about Rx. 1, Rx is for asynchronous events. It's for composing them in particular. 2, Rx stands for reactive extensions, and 3, Rx comes in a lot of different flavors. So I'm giving a talk today in the context of Android for RxJava, but you can do this in JavaScript, you can do this in Swift, you can do this in many different flavors. The 3 key points of Rx are the ones that are on screen now. Rx has observables, it has link queries, and it has schedulers. And I say link queries, it's based on these. It's based on these concepts, even though it doesn't explicitly use them. So between the observables and the queries and the schedulers, we get the world that is Rx. To dive in there, observables represent asynchronous data streams. And this is usually a part that's hard for people to understand when they first come to Rx, so I'm going to really dive into that later. But for now, just assume that they're streams. Queries allow you to compose those streams with operators, and schedulers, unsurprisingly, allow you to manage concurrency within those streams. So to review, these are the 3 core parts of Rx. We can represent asynchronous data streams, we can query and combine those streams with operators, and we can manage the concurrency of those streams with schedulers. So to jump into the first piece of that, observables. Observables, like I said, are streams of data. They're pull-based, with the caveat that you can use some more advanced features in Rx to do some push-based stuff, but in general, they're pull-based. And you can create, store them, pass them around, etc., because they are explicitly executed. And that last point is what I really, really want to drive home. Observables are here because they help us hide away all of the complexity that can come up with threading and synchronization. It's not that that complexity is gone, it's that this library will handle it for you, and we hope that they'll handle it better because that's their full-time job. Rx is usually very difficult solely, or not solely, but primarily because of the concept of streams and of observables. So I was talking to some people last night, asked them how they thought about streams, how it finally clicked for them, and someone said the factory analogy was what really made this make sense. So I'm going to throw this out here. Hopefully it'll help some people. If not, just think of them as streams, but hopefully this will help. So the factory analogy says that you start with some raw material. Maybe you're making cars, so you have steel come into your factory, and this is the raw material. This is our network request. We are starting somewhere. And then once you have that raw material, you send it down a couple of conveyor belts. You might pound it into sheet metal or shape it into the car's body or do something like that. And you also might introduce some other resources from a different factory. Maybe you need rubber to make tires. And as you progress down all of these conveyor belts, you shape it and you add to it. And eventually, when this car gets pushed out the door, you have your final product, which in our case is where we get the data out of the stream. So we put something in, some raw material, we shape it in many different ways, and then at the end, we get the product that we want. All right. Two key phases of the observable life cycle, as I'll call it, although that's kind of a pseudo comparison, is you want to put data into them and you want to get data out. Why else would you have a stream? This is for data. So looking at that first part, putting data in, there are a lot of different ways that you can do that, and I'll show you a few of them. The simplest is by saying observable.just. Here is a string. I only want this, so I'm just going to put that thing in. The second, you can use observables with iterables. So if you have an array, say I've made an array here of me and some of my friends' names, Christina, Nicole, and Allison, I can say observable from this iterable, and what would come out of that observable is Christina, Nicole, Allison, and then it's done. The most heavyweight of any of the creations is using .create. And you'll see here that what happens is I get some subscription S, and I'm particularly managing what's being sent down. In this case, I say subscription, send an on next with this string. I created an observable. And then I don't want to put any more strings in there, so let's just tell you that you're completed. So then I say subscription, you're complete. And this is an observable right here. Nothing has yet happened, but I've built one, and the behavior of it would be it emits this string, and then it completes itself. You might notice that that was not in Java. I have the Java translation below. And if your face is looking a little bit like this right now, I just want to explain why I made that choice. I could not, frankly, fit the Java interpretation on each slide because Rx has some different functions that you have to pass it. And so something like this is a lot smaller than something like this, or you'll see later on even farther than that. And so I hope that you think of this in terms of pseudocode. This is actually written in Kotlin. Some of you may have heard about it. You don't need to know anything about Kotlin to understand how Rx works. So if you think about this as pseudocode, that's a lambda there. I know people are using retro lambda a lot. Hopefully this isn't the first time you've seen it, but if it is, what this function signature says is that I have input to my function s, and I'm going to do these two things to it. And so I'll use this a lot. It's okay if you still look like this. I do apologize, but I just wanted to let you know as we go through this slide, I will be using Kotlin just so I can fit it on the slide, but I'm going to try to explain as much as possible so we avoid as many of these moments as we can. Now, that said, this face may not have been made only because I was using Kotlin. There is also that onComplete there, and that's a little bit crazy because we were doing all of these on next and we were using arrays, and all of a sudden there's onComplete, and what does complete even mean? That's like not even a putting data in thing, that's a getting data out thing. And you're right. So this is a really opportune time to switch over to the getting data out part of observables, because without understanding how you receive data on the other end of a stream, it's really hard to understand how you should put data into the stream. And to that end, remember, these are streams. It's very important for this next slide. So what do we need from a stream? Well, primarily, we want data. We want a way to say, hey, what's the next piece of data? I hit the network. What did I get back? We also want to know, is there anything left to do? Because if they're not, I'm done. I'm going to move on. I'm going to recycle my assets. So we really want to be able to know, hey, should I still care about this stream or can I move on? And lastly, because the world is not perfect, the bane of our existence, did any errors happen that I should know about? What does that look like in code? Well, this is great. I hope you enjoy this as much as I do. When I want something, the next value, I can call onNext. When I want to know if something's completed, I can call onComplete. And when I want to know if something's errored, all right, guess for it. There we go. So hopefully these names make a lot of sense. They're very readable. It's one of my favorite parts about Rx. Nothing should surprise you here. Next value on next, completion on complete, error on error. So this is pretty easy to keep track of, one of the better traits. What does this look like in practice? Well, again, we have that top level function create. So we're saying observable.create. In this instance, I've typed it with string. So this would be an observable that emitted a bunch of different strings. You can put a different type signature in there. And then again, reading this Kotlin as if it's pseudocode, we have some subscription, and we say, all right, I have a function that's very expensive. Maybe it's reading from disk or something. Let me go ahead and do that and get the value back. And once I have that value, let me put it onto that stream by calling onNext. So we call the function, get a value, and we say s.onNext that value. And maybe I'm not done. Maybe now I want to hit the network, or I want to do another disk read, or who knows what. There's some other expensive function again. So I'll call that, and then I'll get the value, and I can push that on the stream as well using onNext again. And maybe I only have those two expensive things. Maybe I have more. In this case, we're done after those two calls, so then I'll tell the stream it's complete, and I'll say onComplete. To go into each of those steps a little bit more, you can call onNext as little or as often as you want. Now, I have an asterisk on the screen because it's not entirely a truthful statement. And to that end, I've linked below to some perf issues that you can encounter if you do this too much. For an intro to Rx talk, you probably will not run into that, but it's something to note that if you're doing really heavy processing, you could run into some perf things, and you want to be careful with this and handle them correctly. Pop quiz with onNext. This is key, and I really want to make sure people get it. So can anybody tell me what this stream looks like? What would the output be? It's not a trick question. It's really as easy as you think it is. 2 and 3, exactly. That's it. It just puts 2, puts 3, and then it's done. Similarly, output for this. It's going to look like apple, banana, orange, pineapple, and I'm done. And to really drive this point home, you can do this as well. You can just build up some binary numbers. It's going to look exactly the same. You're going to output those one by one, and then the stream's going to close. So I feel like there's a lot of mysteriousness around onNext. It really is just that simple. Moving on to onError, it's really key, this one point that I'm about to make. If there's one thing that you take away from this, I hope that it's this, because it'll save you a lot of trouble. OnError and onComplete both end streams. They are both terminal events for streams. The only difference between them is that when you call onError, the stream is ending because something went wrong. And when you call onComplete, the stream is ending because you finished your work, there's nothing to do, move along. But they both end the stream, and the only difference is why the stream is ending. So I'm going to go into that a little more in the next slide, but just another point. One great thing about onError in Rx is that all errors are handled in a single place. So you can combine a bunch of different observables. Any error that happens will be surfaced in your onError. So if it happens far upstream, if it happens downstream, it'll all come to you in the form of the onError. And this is different from things like features, which have individual success and failure callbacks, and then maybe you need to tell another feature about this feature's error, so how do you propagate this, and blah, blah, blah. This propagates down to the lowest level. All errors are here. If you find an error, it'll be here. Look here if you want errors. That's the gist of it. Returning to that first point about terminal events, here's an example that I want to walk through to just drive home this point. So we have an observable. We've created it. We put some try catch in there because there's a function that might error. I don't know what that's doing. Maybe it's hitting the network, but it could error. So in the case that we assume that that function succeeds, we call it, we have an on next, it doesn't hit the catch, and then we do on complete. So that output, it calls on next with whatever value that was, and then it calls on complete. But this is not the case if that function errors. So this is exactly the same observable creation as before, but this time let's assume that function that might error actually does error. You might expect that it would call on next and then on complete, or on error and then on complete. But remember, on error is a terminal event for streams, so what you actually get is on error. That's something that's probably unexpected, so take a moment, let it sink in. After on error, that stream is complete. There's nothing to call on complete for because that's the successful stream ending. We've already ended it in a non-successful way. Okay. On complete, we've kind of glossed over it up until now. It really is what you think it is. It tells you that the stream is done. Go ahead and clean up after yourself, recycle anything that you're holding on to, and basically just move on. So a review. We have our on next, we have our on complete, and we have on error. And each of those do hopefully what you would expect them to do, propagating the next piece of data, telling you that a stream is complete, or telling you that some part of that stream had an error, and here it is. Oh yeah, you thought this was going to be hard? 3 steps, that's it, Rx, all right. Unfortunately, there's more. So if you remember when I talked about link queries, the key point there is that the thing that really distinguishes observables from a lot of different approaches to asynchronous work is that they really, really shine in terms of being able to compose them and transform them in different ways that you need to in your code. And so we're going to dive into operators right now. There are so many operators, I couldn't even begin to tell you all of them. You have operators for filtering and for taking a few and then skipping a few, and for mapping and for flat mapping and for anything that you could imagine, there are operators for that. What do they look like in practice? Well, if you look at this screen, the observable.from of an array is exactly what we saw earlier in the presentation. If we had that observable on its own, it would emit 1, 2, 3, and 4. And then it would cease. It would call its on complete. Here, though, we're adding one extra step, which is a map. And so this map, it has a variable that comes in. So the function is given some variable called number. And what we want to do is we want to say, return number plus 1. So 1 will come down, and we'll have 1, and we'll say, but we don't want 1 anymore. We want 1 plus 1. So 2 will be emitted. And then 2 will come down the stream, and we'll have 2 plus 1, so 3. And so all of a sudden, an observable that used to emit 1, 2, 3, and 4 now emits 2, 3, 4, 5. All right. We can also do filter, another easy example. Here we have the number, and we return a Boolean expression, which is if this number mod 2 is equal to 0, then pass it on. If it's not, then that doesn't get emitted on the stream. So here, 1 mod 2 is 1, so it's not going to get passed on. 2 mod 2 is 0, so it will. So our output goes 1, 2, 3, 4, and after the filter it becomes 2 and 4. This is just a give me evens number function. We can also do things like combining and merging observables. So, all right, I don't have that many friends. They all fit on a slide. So you can see the first one, my school friends. I have Mo and Dave. They're great. Then I have some work friends. I have Nicole and Allison. So there's an observable for them, too. And then at the bottom, I combine all my friends. So I have, all right, let me create an observable from the merged output of my school friends and of my work friends. And this output looks like this. We have Mo, we have Dave, we have Nicole, we have Allison, and then it's done. All the elements of both observables are represented in this output, and then we complete because there's nothing left to process. Now, I left a note here for you. The reason these are in order is because it's just an observable with names that are strings, so it's synchronous. If you were doing network stuff, it's perfectly valid for it to be Nicole, Mo, Dave, and then Allison. They don't have to be ordered like that. Okay, because I cannot cover the rest of them, that was only 3 examples, I'm going to point you to RxMarbles. People have a love-hate relationship to it. I personally think it's great. They have visual representations of what operators do. So I would encourage you to click through there. This is a link on the slides, so if you are looking at these slides later, you can just click through and it'll take you straight there. All right. moving on to that last part, the schedulers. This is where it gets fun because we are talking about asynchronous work. If you do not subscribe, nothing happens. And again, you can see that asterisk because I'm sort of lying to you. There's this caveat here, advanced performance stuff. You probably don't need to know about it right now, but there are a little bit of considerations for this if you are doing something that really that matters for it. But in our context, an intro to Java context, if you do not subscribe, nothing happens. So all of those slides in the past where I was saying observable.create thing, then I put output, that was not totally true. That was the output that those observables would emit, but they did not actually emit it because I never said subscribe on them. I just created an object that if you were to subscribe to it, would have emitted those things. So something about subscribers. They can take a different number of functions. They can take no functions if you just want to kick off that work and you don't care about what it returns. They can take 3 functions if you want to give it on next, on complete, and on error. So maximum of 3, minimum of 0. I'm going to stand up here and really strongly suggest that you always pass at least an on error, because if you don't, your stack trace is going to be completely unreadable and you're really going to hate yourself. So please at least pass an on error to it. It's really important if anything goes wrong for you to be able to understand what went wrong. And then in terms of saying where work should execute, we have these 2 different operators that we can use, which are subscribe on and observe on. And I'm going to go into those later, but just know that that's how we're going to manage where work is run. What does this look like in code? Well, again, not shockingly, I have an array with the same names as always. I say observable.from this array. And then that last line is what's new. I say .subscribe, and then in this case, I'm passing it only one function. I'm passing it an onNext function, and that line there just says, next piece of data I get, print it out. That's it. So the output looks like this. It prints the names, and then nothing else happens. Now, if we want to be more rigorous, we can pass all 3 functions. So this is a full function suite. We pass it on next, which is that first function there. We pass it on error, log the error, and then that last one is on complete, and we'll log on complete. So this output should look familiar. We've added one line here, though, which is it does the on next as it used to, but now we've added an on complete. So when the completion event happens, we have a print. So there's that extra print at the bottom that says on completed. All right, what I have thus far ignored is that .subscribe will return a subscription. You may not need to use that subscription, but it should shock no one that if you have a reference to a subscription, you can call unsubscribe on it. And that looks a little something like this. I call subscribe on some observable, let's say it's the one that I created on the last slide, and then I print something that happens in onNext. So again, it would just print out names or something. And then if I don't care about that work and I actually don't want to listen for it anymore, I can just call unsubscribe because I have the reference to this subscription. So you don't need the reference, but it's really good in terms of cleaning up after yourself if you keep hold of it when you subscribe on something. So this is the meat of observables and of schedulers and of all the subscription processes. What about the threads? Where is my work running? So again, to recap, we have these 2 operators that we can use to tell observables where they should be doing work. Subscribe on should only be used once. You can add it more than once. It's not going to matter. The subscribe on that happens closest to the point at which you create your observable is going to take precedent. So if you call subscribe on the first line on main thread and then 10 lines down you call it on the IO thread, it will subscribe on the main thread. It's going to ignore anything downstream of that. You should use it once, and that's it. It defaults also to the thread if you do not explicitly say where it should subscribe on. It defaults to the thread where you create the observable. Oftentimes this is main thread, but if you create an observable on a computation thread of some sort, you should probably put a subscribe on to make sure it's actually running where you want, because it will default to the computation thread as the place where it runs. And then the key point about subscribe on is that that first block of code is always going to be executed on your subscribe on. At the point at which you subscribe, code will start running on that thread. So maybe down the line, you're doing other stuff and you want to change the thread with an observe on, that's fine. But subscribe on tells you where your code starts executing. That very first block will always run on subscribe on until you get a chance to change it if you so choose. That leads us to observe on. maybe you've subscribed on one thread, maybe it's a computation thread, but now you want to surface something and put it in the UI, so you want to switch back to the main thread. That's where Observe-On comes in handy. You can use this as many times as needed. There's the dreaded caveat again. There's some back pressure issues. Again, if you're not doing really, really performant required things, you probably won't run into this, but if you are, it's in the notes. And it is important to understand with Observe-On, it affects everything downstream. So if I put an observable on line 2 of a 10-line observable chain, it will affect lines 3 through 10. Unless I put another observable on line 6, or Observe-On on line 6, in which case that observable now will affect everything downstream of that. So everything below your Observe-On will happen on whatever thread you tell it to observe on. And we can look at that in code. I'm going to build this up line by line, because if I splash it on screen, everybody's going to run out the back door screaming. So this is going to go line by line. So we start with an observable. You've seen this a million times at this point. It's just going to emit a bunch of colors. That's it. Now, I'm going to add a doOnNext. You haven't seen this yet, but doOnNext is somewhat self-explanatory. When onNext fires, I'm going to do this function that I provide. In this case, the function that I provide is just a log. I just wanted to print out what thread it's occurring on. So that's all that's going on there. Print the thread when onNext happens. Now, maybe something else needs to happen, and I don't want it to be on the thread, that thread anymore. So I put an observe on, and I say, all right, let's switch our thread over to I/O. And then I want to do something like map it. I have a string of colors. Maybe I only care about the length of the string. That's what's important. So I'll say, all right, take this string, and then instead of having the string, give me back the string's length instead. And then you get the full finished product. I add that subscribe. It prints out the thread that I'm finally getting my output on. So what does this output look like? Well, it starts on the main thread because I didn't give it a subscribe on, and I wrote this observable on the main thread in my sample app. And then after I switch over to the I/O thread, unsurprisingly, it starts emitting things on the I/O thread. So you can see in those bottom 3 lines, it says that we're on the I/O scheduler. Now, let's say I want to use this explicit subscribe on. I don't want this to be run on the main thread. This is exactly the same observable we just built up line by line, but there's a subscribe on call there, and I put it on the computation thread. How does that change things? Well, now you can see that that very first work that was done, it was done on the computation scheduler. And after that, once we switch over to the I/O thread and we map it to the length, that's happening on the I/O scheduler. And so this is one of those examples where you can see that we can start work in one place, we can switch over to a different scheduler, and it can be done elsewhere. I could also add a different observe on to put it on main thread, and it would just, you would see that ripple through the output as well. All right, Rx and Android. I haven't talked about Android at all. I've just been going through observables and RxJava in general. Let's talk about how this can impact your life as Android developers. So, again, this is just like operators. I can't tell you all the ways you can use RxJava in your app because the sky is the limit. Whether you should be using them in places is a totally different question, but you can use it in many different places. Here's just a few somewhat contrived examples. You can bind clicks and then filter for a certain quadrant, or you can see if people double tapped by using kind of an aggregator on your observable given a time frame. You can flat map cache hits with the network. You can handle offloads in a single stream, so you get user input and you send it to the network, and then you get a response back, maybe hit the network a second time, fetch user details. All of that can happen in a single stream. And I'm going to walk through a few examples, but before I do, just want to say they're here to give you flavor on what this can look like in an Android app. If you don't understand all of them, that's okay. The idea here is to just get a notion of what is possible. So here's an example of debouncing a button. I'm not sure why you would need to do this, but you can do it. And so what's happening here is I'm just adding something to a button class called debounce. I can give it some unit of time, and then I can start with saying set enabled to false. I'll set a timer observable. It'll fire. When it fires, I set enabled to true. So obviously, in the time that set enabled is false, users won't be able to click on this button. And then after my time has elapsed and onNext has been called and enabled false is turned to true, then users will be able to click again. You can do things like, I used to work for a photo sharing app and we had a bunch of photos stored in our DB. So one case that we use, this is a pared down example of it, is I would get my database with the context and I would say, hey, load up some photo details for me. I really care about the most recent ones though, so can you order those by timestamp for me? And then, oh, by the way, I can't deal with that many at once, so just give me like the last 24. That's all I really care about. And then maybe all I care about is the size of those photos. I want to do something with the UI, who knows? So then that last line just says, hey, instead of photo details, just give me the size of the photo. Map it to its size. And this may look very dense. It is. If you tried to do this without Rx, you would, this would be a 5-page slide. This would just go on and on. I would be flipping forever. And so the fact that you can do this in 6 lines is incredible. This is really complicated stuff, and it's pretty readable. You can do the canonical example of I/O. You can maybe download something. We have some function that writes an output file. I don't know what's going on there, but we get a file back. Maybe we check the type. If it's a photo, put it somewhere. If it's a video, put it somewhere else. If it's none of those, then what is going on here? Throw an error. And then in this case right here, we're not sending data through the stream because we don't care. What we're using this observable from is that toast that comes up and says, download completed or download failed. So we don't actually need to send that file down the stream because we have no use for it. All we care about is, did this complete or did it fail? So you'll notice there that we have the on error if it errors, if we don't know what type of file, we don't know what to do with it. And if not, we just fire on next with no argument. Unit is the null type here, so it's just saying fire on next, but I'm not going to give you any argument to your on next function. It's just going to exist. And then we say, all right, we're complete here, wrap it up. You can see also there's a subscribe on I/O, so you can put a subscribe on. There's also ways to lift things from local broadcasts. So this is an example of one of the things, all of those apps that give you codes, they text you codes, and then you have to input them into your app, and that's how you auth. Android's great because you can scare people by just reading their text messages. That's fun. And this is an example of that happening. So someone sends you a code, you auto-read their text message, pull that code out, and get it in a local broadcast. But local broadcast can be a little bit clumsy, so let's go ahead and transform that into an observable. So what's happening here is we have the intent filter to get the verification code. And we give that to a content observable.from local broadcast. And then we don't actually need the intent here. That's not what we're interested in. What we really care about is just that verification code so I can make sure it's the right one. So that last line just says, you gave me an intent, but really all I care about is the verification code. So pull that out of that dictionary. And you can see that the return type is a string question mark. That just means that string could exist or it could be null. So if that key doesn't exist in my intent, it's just going to return a null. If it does exist, it's going to return the code and I can do further checking. You can also build up really complex onboarding flows. This is pared down in sort of pseudocode, but a timed auth observable is kind of that situation that you run into where you input your credentials and it's seeing if they're valid, so you see the spinner, but then maybe you're in bad network, so it will come up with like connection failed, then you hate yourself. So that's a timed auth observable. And then you can put that on the I/O thread because you're hitting the network. And then maybe you want to do things downstream. What this is not important. I've kind of added some pseudocode, like you want to verify your response, and then now that you're logged in, you want to get a suggested username so they can finish onboarding with their suggested username. So what's going on here is less important than how it's going on, which is that your entire auth flow is now in these 8 lines of code, and you're managing where that code is running very easily by using observe on and subscribe on. You can also do things like this. You can, if you're not authed, kick off an I/O event to get authed. And then once you're authed, you can then call a function, now that you're authed, that hits an auth response. This is not easy to do without observables because you have something that's getting the authentication, and then you store that, and then you kick off this totally separate task that does the auth result for you. Here, it doesn't matter that you're unauth to start because by the time you get to that flat map user service auth client, you are authed because that's the way streams work. You go from the top of the stream to the bottom so that by the time that function gets hit, you're authed. Or an error was thrown, and you'll know that the error is thrown. So this is really powerful. It may not look like much, but you can start out as a not logged in user, and you can compose that with logged in stuff downstream after your I/O. All right, that was a lot. Let's summarize. You guys still with me? Okay, I'm not here to tell you that Rx is the only game in town or that it's always the right solution. As you've seen in this presentation, there's a lot of things that are non-trivial about it and that can be confusing. So that's not my point. But my point here is that Rx is one of the most powerful games in town. So while it may not be right for everything, if you're doing really high performance stuff, if you're doing stuff where you hit the network or you're reading from disk a lot or you're doing a lot of asynchronous work, it really can be the right tool for the job. It's heavyweight, but that comes with a lot of benefits, which is that it can do a lot of stuff. There's a steep learning curve. I get that. It sucks. It's like walking on glass, as we were talking about last night. It's unpleasant. But once you master it, it can really help you reduce errors. So once you learn to think in this way, things become a lot easier to read because they're mapped together in a logical chain of events. You can see that something hits the network, gets transformed, and then is put on the UI thread to be used by your UI. And you can see that all in one place. It's not going off and disappearing somewhere. You're not storing it in state. It's all in a chain. That chain represents an entire action. And you aren't introducing extra opportunities for errors by using stateful storage. And then lastly, I get that streams can be a huge paradigm shift. We don't think like this often because it's just not how most apps are built. But if you can switch over to thinking of data as streams, your entire app's data flow can be brought to the surface. So right now, when you're using other async primitives, what can happen is you send something off to a thread here, and then maybe there's a thread here, and then this activity is doing something, and I mean, who knows? You can have asynchronous stuff going on in a bunch of different places. What happens if you use threads is that it forces those to be connected. And so you can easily write a GUI, and these actually already exist, where you kick off a network event, and you can see exactly where it flows through your app, all the way to the point that you stick it in your UI or put it somewhere else to be used later. So the first call to the network, the transformations when you're bringing in other data or filtering data or reducing data, all of that can be surfaced in a GUI, and that's powerful because it gives you a way to talk about your app that everybody can understand. If you have a roadmap, you know where you're going. And that's really, really useful, not just for developers, but for product people, to tell them how the pipeline works, where you're getting your data, how it's changing, and where it ends up. So lastly, this is the best summary that I can give you about Rx. If you have a car, if you have some old clunker of a car, and all you're doing is going to the store, that's absolutely fine. The streets are what, 25-mile-per-hour speed limits? You can make that. And like, yeah, maybe the seat's not so comfortable, but you can adjust to fix that and just kind of get comfy over in the corner. And maybe it doesn't start up and you kind of have to jiggle the key, but that's fine. It works and you get there and it's great. However, if you have to go cruising for road trips or you're getting out on the freeway, I guarantee that if you bring a Tesla and you bring an old car, you will notice the difference because the power is there, the safety is there. They've learned a lot in the last 20 years about driving. So that Tesla, I mean, have you seen its safety record? It's world-renowned. And that's because they've watched what's happened before, they've corrected for those mistakes, and they've built it into new technology. So yeah, if you're going to the store with your Tesla, you probably won't notice that much of a difference because 25 miles per hour is not what that car is built for. You don't need to go 0 to 60 to get to the grocery store. It may not be your best option. But if you were, yeah, right? Like peeling out in the parking lot, you're going to get arrested real quick. But if you were driving across the country, if you were doing something bigger, something more complicated, something longer lasting, if you were doing something more monumental, the Tesla is what you want. It fits that use case. It'll make your life more enjoyable. You'll be safer doing it. And it's just going to be, quite frankly, a lot more fun. So I'm going to point you to a few more resources. I know I couldn't cover everything. There's RxMarbles and other documentation. Dan Liu also has a great series of blog posts on this topic. He's here, so you can also bug him in person if you want. I'm going to throw him under the bus here. I think that they're really easy to understand. They were helpful to me when I was getting started. Also, the slides are live. Okay, again, caveat, they will be live as soon as I walk out of this room. I put, as you saw through this presentation, a lot of documentation under the fold. So every one of those Kotlin functions that I wrote has a Java translation below the fold. So if you press the down arrow on any one of these slides, you'll find links to more resources in the translation and the output and anything else that you want in reference to that slide. Also, I'm online. If you want to yell at me or ask me questions or any of that sort of thing, you can find me on Twitter at @RunChristinaRun. And that's all, guys. Thank you.